In this video, we're in lesson 1.1. We're on page 5 in your student journal, and we're going to work through number 2, 3, and 4. In these 3 problems, we need to identify the function family to which f belongs. We're going to compare the graph to the graph of its parent function. And then we're also going to add in discussing the domain and range of the function that's graphed. So in number 2, we first have to identify, okay, what kind of function is this? What family does this belong to, and what's the parent function? So this is a horizontal line that is a function in the constant family, and the parent function is f of x equals 1. So I'm just going to go ahead and in purple just sketch the parent function. Okay. Our parent function is, we'll just call it g. G of x is equal to 1. Okay. And we're going to use that to help compare this graph, f of x, to the parent function. So we're asking ourselves, how do we go from the parent function to our new function? What happens? We can see that it's a shift or a translation down 4 units. Okay. So it compares because it's a translation 4 units down. Okay. Now let's talk about the domain and range of this function here. Domain, remember, is the set of all possible x values of our graph. So you're going to think about, okay, all the points on this line, what are all the possible x values? This goes forever in both directions. It goes forever in the positive x direction and forever in the negative x direction. So it hits all possible numbers, all real numbers. So our domain is all real numbers. Range, remember, are the possible y values of the graph. I think up and down. Of all the points that are on our graph here, what are all the possible y values of those points? Well, all the points on this line all have a y value of -3, right? On this y-axis, this is a value of -3. So the range, the only possible y value of points on our graph is -3. So our range is y is equal to -3. Let's move on to number 3. We need to compare this function to the parent function. This graph looks like a V. So remember, if we're looking back at our notes, the absolute value functions look like V's. So this is part of the absolute value function family. The parent function is the absolute value of x. Let's go ahead and graph that so we can compare it to the new function. Okay. You should start to be able to get into a habit of being able to graph this really quick. If you're struggling, remember you can always make a little table and choose some x values. I'll choose -1, 0, and 1. So if I plug in -1 in for x, the absolute value of -1 is +1. If I plug in 0 for x, the absolute value of 0 is 0. And if I plug in 1 for x, the absolute value of 1 is 1. This helps us kind of get the overall shape and plot some points in order to graph that parent function. Just be careful, this graph, it counts by 2's if you didn't notice. So I'm going to go ahead and graph this. -1, 1, 0, 0, 1, 1. It creates this V here. So this is what the parent function looks like. And we want to compare that to the function that's graphed here. You can tell that this is skinnier. Okay? It looks like it's been stretched up. It's been stretched up and away from the x-axis. So this is a vertical stretch. Let's find the domain and range of this new function. So for the domain, we're interested in what are the x values of this function. So think left to right. How far to the right does it go? How far to the left does it go? This function here has arrows pointing, so it means it goes forever in that direction. It will continue to go forever in the right direction, and it will continue to go forever in the left direction. So it will hit all possible x values, all real numbers. The range, think up and down. What are all the possible y values of this function? It definitely has a lowest point here, and it will go up forever. There are no points on this graph below the x-axis. So all the points that are on this graph are positive y values, 0 or positive. And so all of the y values of our graph are greater than or equal to 0, because none of the graph falls below that x-axis. Number 4, this graph is a parabola. Okay, a parabola has that U shape. That means it belongs to the quadratic family. So the parent function is x squared, y equals x squared. Again, let's graph that so we can compare our graph to the parent function. If you need help graphing, again, you can always create a little XY table to just get some points that you can graph on the graph. So I chose some negative and positive values. If I plug in -2 for x, -2 squared is positive 4. If I plug in -1, -1 squared is positive 1. If I plug in 0, 0 squared is 0. If I plug in 1, 1 squared is 1. And if I plug in 2, 2 squared is 4. I'm going to go ahead and graph these points on my graph. Notice again, this particular graph counts by 2's. So I'm going to plot -2, positive 4, -1, 1, 0, 0, and it's going to have that symmetry. Okay. So comparing my parent function, my purple graph, to the new graph, you can tell a translation has happened. It has slid. It did a slide, right? If I look at this bottom point, this minimum here, I can kind of compare. It went up and to the right, right? So it was a translation. Let's see how far up it went. Remember to count by 2's. It went up 4. Translation 4 units up. And how many to the right did it go? Remember, we're counting by 2's. It only went 1 to the right. Okay. Finally, let's give the domain and range for this graph here. Okay, x values, ask yourself, okay, how is it moving left and right? Kind of like the absolute value problem, this graph goes forever to the right and to the left. So it's going to hit all possible x values, all real numbers. Range, we're looking up and down. Okay, you can tell the graph starts here. This is the lowest y value it will have. There are no y values below that point, and it will go up forever. So this y value here is 4. So all points on this parabola have a y value of 4 or more, right? 4 or greater. So the y values are greater than or equal to positive 4.